Bismillahirrahmanirrahim. Hello everybody. I hope you're all fine and going well. Today I am going to discuss about the third part of sum to product formula. In this part we will study tangent A plus minus tangent B. The first one is tangent A plus tangent B. We know that tangent of an angle is equal to sine of that angle over cosine of that angle. Here the angle is A and B. Tangent A is equal to sine A over cosine A plus tangent B is equal to sine B over cosine B. Here we have two fractions to add. If we add these two fractions, at first we should have a common denominator. If we take a common denominator, we will have cosine A and cosine B as a common denominator. And after addition, in numerator we will have sine A cosine B plus cosine A sine B. We know that sine A cosine B plus cosine A sine B is the form of sum of sine. It means if we have sine A plus B, this is the sum formula of sine function, and this is the expanded form of sine function for sum. Sine A plus B is equal to sine A cosine B plus cosine A sine B. So we are writing sine A plus B instead of these terms, and the denominator will be remain on its own form. So our sum to product formula for tangent function is tangent A plus tangent B equal to sine A plus B over cosine A cosine B. It means that if we have two angles for tangent function, and if we add these two ratios, we can add from this formula. But this was for sum to product form. If we write minus B instead of B, what will be the form of the formula? So the form of the formula will be like this: tangent A plus tangent minus B. Here sine A, if we put minus B instead of B, here we will have A minus B. Also in denominator cosine A multiplied by cosine B. Here we have tangent minus B. Tangent of minus alpha is equal to minus tangent alpha. So here we are writing tangent A minus tangent B. Here sine A minus sine B, and in the denominator cosine of minus alpha is equal to cosine alpha. So no change is occurring in the denominator. So tangent, so the formula for difference to product for tangent function is tangent A minus tangent B equal to sine A minus B over cosine A multiplied by cosine B. Only a single minus sign is the difference between these two formulas. So these were the formulas for sum to product for tangent function. Now I am going to solve some examples in these formulas. The first example is to evaluate tangent of 75 degree plus tangent of 15 degree. Here, how we can solve this example? We can solve when we apply the sum to product formula for tangent function. We had the sum to product formula for tangent function here in ninth relationship. We are applying that relationship. We are writing sine of 75 degree plus 15 degree. In denominator cosine of 75 degree multiplied by cosine of 15 degree. So if we add 75 with 15, that will be sine 90 degree. And here cosine of 75 degree, we can write this as sine 15 degree because sine and cosine are co-functions of each other. And cosine 15 degree. Here we are writing sine 90 degree over, we can apply the double angle formula in the denominator. So here we have sine and cosine, but we don't have multiplied by 2. Here we are going to multiply this term by 2 and divide by 2. This can be cancelled with each other, but from 2 sine 15 cosine 15 we can get sine 30 degree because of applying double angle formula. And here we are writing 1 instead of sine of 90 degree, and this is changed to sine 30 degree over 2. So we are just putting the values of these ratios here. We have 2, and instead of sine of 30 degree we are writing 1 over 2. This will be written in the numerator, and after multiplication the answer will be 4. So sine tangent of 75 degree plus tangent of 15 degree is equal to 4. So this was our first example. In our second example we have a sine of 10, if sine of 10 degree is equal to t. So evaluate tangent of 70 degree plus tangent of 10 degree in the terms of t. It means that your answer will be contain t. So we are writing and applying the tangent formula, the sum to product formula for tangent function. Tangent of 70 plus tangent of 10 is equal to sine 70 plus 10 over cosine of 70 multiplied by cosine 10. If we add this, this will be sine 80 degree over sine, we are writing sine 20 instead of cosine 70 degree because these are co-functions of each other, and cosine of 10 degree will be written on its own form. So sine 80 degree over of sine 20 multiplied by cosine 10 degree, we can write cosine 10 degree instead of sine 80 degree because these are also co-functions of each other. So cosine of 10 degree will be cancelled with cosine of 10 degree. Here we will have just 1 over sine 20 degree. Here we are writing 1 over sine 2 multiplied by 10 degree, and we can apply double angle formula on this ratio, and we will write 1 over 2 sine 10 degree multiplied by cosine 10 degree. We know that sine of 10 degree is equal to t. We can write 2 multiplied by t. But what we will write instead of cosine of 10 degree? We can get cosine in the terms of t from a trigonometric identity. We have a trigonometric identity that sine square alpha plus cosine square alpha is equal to 1. So here we will have different angles. We can write sine square of 10 degree plus cosine square of 10 degree is equal to 1. So we can write t instead of sine 10 degree. We can write t square plus cosine square of 10 equal to 1. If we if we obtain cosine of 10 degree from this equation, t square should be take away to the right side, and this will be cosine square of 10 degree equal to 1 if we take this to the right side, that will be 1 minus t square. So if we want to obtain cosine 10 degree, here it has a power, so we should take both sides under a square root, and cosine of 10 degree will be 1 minus t square under a square root. So we can write this 1 minus t square under the square root instead of cosine of 10 degree. So this will be our answer of this example. This was our today's lesson. Hope you understand. Thanks from your watching, and have a good time. Best of luck.